This week is week 5. Before we move on to the next lesson, I want to go over the Alphabetia homework for you guys. So the first problem was this. What base 10 number does each of the following represent? Draw the units, longs, flats, and the cubes that represent the numbers, right? We're talking about here in base 5. So we know when you have 5 units, you can regroup that as one long. And if you have 5 longs, you can regroup that as one flat. And when you have 5 flats, you can regroup that as one cube, etc., etc. So we know that this is the ones, right? Units. This is longs, flats, and the cubes. So this will show you that you have 4 cubes where you have 5 by 5 by 5 units there. So you have 4 of them. 1, 2, 3, 4. They have to be the equal size, right? Okay, so 5. Okay, you have 4 of these cubes and you have 1 flat and you have no longs and you have 2 units. So this is what you have, right? But we know in one cube we have 5 by 5 by 5 units. So how many units are there in total? 5 cube many, right? And you have 5 cube many units here, and same here, and same here, right? And here in the flat you have 5 by 5, so it's 5 squared, and this is just 1 in each, right? So we can add these together to change base 5 to base 10. So we have 1, 2, 3, 4 in each 5 cube many units, and we have 1 flat. So we have 1 flat, and in each flat you have 5 square many units, and you have 2 units. So in total, what is 5 cubed? Is that 125? Right, so 125 times 4, 125. What is 125 times 4? I want you guys to calculate that while I'm writing these. 1 times 5 squared. 5 squared is 25. So 1 times 25, or just write 25, because we know using the identity property of multiplication, 1 times 5 squared is 5 squared, right? Plus 2. So what is 4 times 125? It is 500, and you have 25, and you have 2. So total you have 525, 2 more, 527. That's in base 10. So 4102 in base 5 is exactly same as 527 in base 10. You can do the same thing here. For base 4, let's use different color. I'm going to use a little bit thicker. Okay, so 1111 in base 4. We know this is the unit, longs, flats, and the cubes. So you have 1 of each, right? In 1 cube, we know that there are 4 by 4 by 4 units. So it's gonna be 4 cubed, right? In a flat, you have 4 by 4. So it's 4 squared. What's wrong with this writing today? 4 squared, right? And in this one, you know, it is 1 long. And in 1 long, we have 4 units. And there is 1 unit. So we can just add these together. You have 4 cube many units in 1 cube. And you have 4 square many units in 1 flat. And in 1 long, you have 4 units. And there's 1 unit left. So when you add all of these together, what is 4 cube? Is it 64? You can have it's equal to 60. What's wrong with this writing today? Sorry about that, guys. So 64 plus 16 plus 4 plus 1. How can you solve this easily? Well, if you group this together using a social property, you get 20, and you have what? 84, and you have 1 more, so it's gonna be 85, right? 85. So 85 in our number system in base 10 is exactly same as 1111 in base 4. Okay, that was the first problem. And the second problem, what base 5 number does each of the following can be written? Draw the units, longs, flats, and cubes that represent the numbers. We are doing base 5, so we need to understand that in a cube, in base 5, you have 5 cube. So you need to have 125 to make 1 cube, but we don't have that many. So you can lower it down 1 place value, then it's gonna be 5 squared, right? 5 squared is 25. So we're gonna see how many 25s we can make out of 56. Yeah, we can have 2 flats because then we use 25 and 25, which is 50. So there will be 6 left. In 6, we know we can also use a long because that contains 5 units. So far we have 25, another 25, which is 50. You can have 1 long there, and that makes together 55, because 1 long contains 5 units. But to make 56, we need to have 1 more unit there, right? So we can see, there are 2 flats, 1 long, and 1 unit. So in base 5, we have 1 unit, 1 long, and 2 flats in base 5. Okay, so this is gonna be your answer. How about 307? 307, we can do the same thing, right? So 5 cube is 125, and 307 is much more than 125. So you can use all of that, but we need to consider how many cubes we can have. So if you have 1 cube, you can have 125. If you have another cube, that makes 250. Right? 250. Can we have another 125? If you add another 125, it's gonna be 375, which is too much for 307. So we are done with the cube, and then you're gonna consider how many flats you can have. Each flat has 25. So if you add 25 to it, what do you get? 275. We are getting closer and closer to 307, right? Can we have another 25? Yes, because when you add another 25, that makes 300. Right? We cannot have another 25 because then we're gonna have 325, which is much more than 307. So let's think about long. In 1 long, we can have 5. So if you add that, you have 305. Can we have another long? No, we can't. Then you're gonna have 310 because, and that's bigger than 307, so we are done, right? For the longs. But since we need to have two more to make 307, we can have 2 units there. So as you can see, I have 5 cubes here, 5 cubes here, and 5 squares here, 5 squares, 5 and 1s. So I have 1, 2, 3, 4. Excuse me, 4 digits. 1, 2, 3, 4 digits. And we know we have 2 cubes, 2 flats, 1 long, and 2 units. This is also in base 5. Okay, let's look at the third problem. I want to change the color, like this one. Calculate below. 411 in base 5 plus 334 in base 5. So it's a little bit advanced, right? So when we have 411 in base 5, 3 plus 334. We can think about same algorithm that we are doing in base 10. You need to consider how you can do the regrouping there. 4 plus 1 makes 5. When you have 5, you need to regroup it, right? 5 units is the same as 1 long. 1 long. So we can regroup that as 1 long, but there's no units left. Then how many longs do you have? Now you have 3, 4, 5 longs. When you have 5 longs, you can regroup that as 1 flat, and there's no more longs left. When you have 5 flats, that is the same as 1 cube, and there's only 3 flats left, and you have 1 cube there. So this is 1, 3, 0, 0 in base 5. How about 402 minus 343? You can do the same thing, right? So 402 minus 343. This is also base 5. Okay, so you need to think about regrouping. So let's think about subtracting 3 from 2. You cannot do it, so you need to regroup this and carry that over. However, you don't have enough, so you need to regroup the flats. So you have only 3 flats, and you gave the 1 flat to the longs and change that to how many longs? Yes, 5 longs. But since once the units need 1 longs, we're gonna give 1 long to this one. How many is 1 long? We have 5 units there, right? So total there is 7. 7 minus 3, you have 4. 4 minus 4, there's no more longs. 3 minus 3, there's no more flats. So there's only 4 units left. This is in base 5. Last problem, this is the bonus. Draw the units, longs, flats, and cubes that represent the calculation of 344 plus 222. So 344 plus 222. This is also in base 5. 2, 2. So when you are adding this together in base 5, you need to think about the regrouping. Whenever you reach to 5 of each, you need to regroup that and carry over to the left, right? So here, 4, you need to have 1 more to regroup and make it as long, and you have 1 unit left. So there's 1 more long there. This makes another 1 flat. So you have only 2 longs left, and here you have 1 flat. I mean one cube, right? 3 and 2 flats make 1 cube. So you have 1 more long flat there. So this is gonna be the answer, but I ask you to draw these, right? So let's see how you can draw. 344 is what? 3 flats, 1, 2, 3 flats, 4 longs, 1, 2, 3, 4 longs, and 1, 2, 3, 4 units, plus 2 flats, 2 longs, and 2 units. When you add this together, we know that we can have these together to make another long, right? And these 5 of these make another flat. And we know 5 of the flats will make another cube. So I want you to represent each of these followings of regrouping and carried over, regrouping, carried over, and so on. So we know there's 1 unit left here, right? And you have 2 longs left, and you have 1 flat left, and you formed another 1 cube. So that is your answer in base 5. So I want to see, how you regrouped it and carried over, and regroup it and carried over, okay, using the manipulatives. Alright, so that was the Alphabedia homework, and today we're going to move on to week 5, problem solving. Okay, so this week we're going to focus on problem solving. Okay, and I'm giving you one problem here. I want you to read this carefully and solve the problem. And if it's possible, for your grade level, if it's matching, you can play this with your students too. Okay? So Jimmy Jingle was having a detective party for some of his new friends. He gave directions to his house, but decided not to give the house number. Instead, he gave his new friends some clues to see who could find his house on Bell Street. Here are Jimmy's clues for his house number. The number is greater than 50. I want you to solve this problem, guys. The number is greater than 50. Second clue. The number is less than 90. Can you find the number yet? No, we can't yet, right? Okay, so I'm gonna give you another clue. The 2 digits are different. It says 2 digits are different. So we are limiting by step, right? From here, we are limiting the number less than 90. We are limiting the number eliminating the 2 digits are the same, right? Like 55, 66, 77, 88, they're all gone. So we are making, we are narrowing down by giving more clues. Next clue, the tens digit is larger than the ones digit. So we're limiting again, right? Okay, so all the numbers like 92, something like 89, 78, 79, 56, 57, they're all out, right? So tens digit should be larger than the ones digit. And it is an odd number, so all the even numbers are out. Did you get the answer yet? Probably not. And then it says the sum of each digit is 15. So using this, do you think you can find the answer easily? What's your strategy to find the answer? What helped you to think better? Maybe some of you used a number line. Maybe some of you used, I don't know, maybe you wrote the numbers, all of the numbers, maybe between 50 and 90. Yeah, they may help. So some of you even think that 100 chart like this will be helpful. So let's consider the clues one more time, okay, using all of these numbers from 1 to 100. The first clue, Let me use this one. The first clue was this. The number is greater than 50. So you need to cross out, you can cross out all the numbers that is less than 50, less than or equal to 50, right? So these numbers are all out. We don't have to consider these numbers. The second clue is the number is less than 90. So any number that is greater than or equal to 90, we don't have to even look at them. So these are all out. The third clue, the two digits are different. So you need to cross out all the numbers that are both digits are the same, like this. These, they are out. Fourth clue, the tens digit is larger than the ones digit. So if tens digit is smaller than ones digit, we need to cross that out. So all of these. But this one, tens digit is greater than ones digit, so we need to keep that. Tens digit is not greater than ones digit, so cross them out. Same here. Same here. Right? So we see a lot of numbers are crossing out. More and more numbers are crossed out. So let's look at the next clue. It is an odd number. So let's cross out all the even numbers. All the even numbers, they are out. So you see how we are narrowing down. So when you're making problems, you need to think about narrowing down clues, okay? So teachers need to think more. Okay, now it says the sum of each digit is 15. So 5 and 1 together is not 15. It's 6, it's 8. What else? 7. Together it's 9. Together it's 11. That's 8. That's 10. That's 12. So nothing. That's 9. Together it's 11. Together 13. The only number left is 87. And the sum of these two digits is 15. So we narrow down all the way to only one number, which is 87. So by doing this activity, this kind of problem solving, what did you notice? Maybe you're thinking about the order of the clues. The order of the clues. So here are the order of clues, right? We were narrowing down step by step. It's not randomized, randomly given to you. You need to narrow down the numbers. So systematic, right? What other things did you notice? I also think that the tool, manipulatives, or any representation, they are helpful, right? So in our case, base 10, not that base 10, I'm sorry, 100 chart was very useful. So using tool is very, very useful. If you are doing in your classroom, you can even lead the discussion here. By giving each clue, students can discuss to debate which numbers have to be crossed out and which numbers are left, and so on and so on. So using good quality of problem, you can even think a lot of things, right? And make students to discuss, and there are different concepts that you can also think about. So for example, we can talk about greater than, less than, the digits, place values, and we can talk about even and odd and the sum of each digit, right? So there are a lot of things that you could discuss. So I want to show you Singapore math and some problem solving in Singapore math. A lot of you already know that Singapore math is very prestigious curriculum, math curriculum, especially TIMSS, TIMSS tests. You can see that in consecutive years, TIMSS test is given to the students every 4 years, but since I don't remember when, but Singapore was always the top in the math. Okay, so some of the school districts and some private schools adopted Singapore math and their problem solving approach is very, very helpful for the students to understand what's going on. So we're going to talk about that a little bit. Okay, so concrete pictorial abstract approach is the Singapore model, and I want to show you this video a little bit.
The concrete pictorial abstract, or CPA approach, develops a deep understanding of math through building on existing knowledge. This highly effective framework introduces concepts in a tangible way and progresses to increasing levels of abstraction. In the concrete stage, students interact with physical objects to model problems, and teachers may lead a classroom activity. The physical objects could be the actual objects used in the problem, or manipulatives representing the items. For example, in a math problem where students are solving for the number of stickers, students might count real stickers, or manipulatives representing the stickers. In the pictorial stage, students make a mental connection between the objects they just handled and visual representations of those objects. Moving from the real stickers of the concrete stage, they are now using drawings of stickers in the pictorial stage. Visual representations can also include number bonds and bar models. In the abstract stage, students make the leap to using numbers and math symbols to model problems. By varying the methods and stages of the CPA approach fluidly, educators help reinforce important connections. All lessons don't include all 3 CPA stages, as application of this approach varies by topic. However, CPA principles are woven throughout our curricula to help students work towards math mastery by working through concepts with increasing levels of abstraction over time.
Okay, so CPA model is very, very useful. Okay, starting from concrete model, pictorial model, and then we can go to the with numbers and stuff. Okay, so here's one example. 5 birds are on a branch. 2 more birds come. How many birds will be on the branch altogether? For concrete model, a concrete stage, you can show actual pictures of birds that represent the situation. Or another activity that you can do with your students is like students represent the birds. Having 5 students go to the front of the class and having 2 more come over, so that represents the situation. And you can ask the students how many students are there now, so they can explain what had happened. Okay, so it's a very tangible way using concrete models like that. And for pictorial stage, instead of using concrete that represent exactly the similar way, but instead they can use manipulatives like Unipix cube. These are very helpful, and that connects with the number sense here. This represents 5 and this represents 2. So when you have 2 parts, each 5, one with 5 and the other with 2, how many are there all together? You can connect that, right? Then in abstract stage, you can add symbols like addition or equal sign. So students can have that relationship. Another thing that I really like is this one is a bar model. Maybe some of you can think about other models like using counters or number lines. They're really good too, but you are very familiar with it, so I'm gonna introduce you this model because it's heavily used in Singapore curriculum. So Kylie is 7 years old. It's represented as just random bar. If this is 7, her sister Madison is 4 years older than Kaylee. So we know that Kaylee's sister Madison is longer. Her bar should be longer by 4 because she's 4 years older. How old is Madison? So that's the question. How can we count? We know that Madison's age is Kaylee's plus some plus 4. So part and a known part of 4 together is the whole. So you can also teach part, whole there. Okay, so we can find this is 11, 7 and 4 more. If you're thinking about the counting technique that we talked about, you can just count on from 7, just count 4 more, 8, 9, 10, 11. So 11 is another number, Madison's age, right? Think about this one. Chapa saved $32. Emily saved $14 more than Chapa. Ivy saved $17 less than Emily. Can you use bar model to represent the situation? I want you to pause the video and represent this in bar model. If you're done, you can think about different models, okay, like number line or some other method too. Okay, so once you're done, you can think about this way. Chapa saved $32, so Chapa's money saved is represented in a certain bar here. Emily saved $14 more than Chapa, so Emily's should be $14 more. It should be longer. The difference here is 14 because 14 more than Chapa's, right? And Ivy saved $17 less than Emily. So from Emily's, you can subtract 17 there. So this bar model shows that Emily's should be 32 plus 14, which is what? 46? Yes, and Ivy's is 17 less than Emily. So Chapa's is done to find Emily. Now we're gonna use Emily's saved money to find the Ivy's. So from 36 you can subtract 17 and get, what is it, 29? Okay, so bar model is very helpful, right? Now I wanna introduce you problems of the month. This is very unique activity that you can do with not only one single class, but with the different levels. Kindergarten with 5th grade, 2nd grade with 4th grade, things like that. Okay, so let me introduce you this a little bit. Let me just read it for you. The problems of the month are non-routine math problems designed to be used school-wide to promote a problem-solving theme at your school. Each problem is divided into 5 levels of difficulty. Level A is primary through level E all the way to high school, to allow access and scaffolding for students into different aspects of the problem and to stretch students to go deeper into mathematical complexity. The problems of the month were developed by the Silicon Valley Mathematics Initiative and are aligned to the Common Core standards. Even if your state does not use Common Core state standards, it's still relevant. Okay, so I'm gonna show you 2 video clips, very short ones, and then I'm gonna give you the homework. So this one is overview of the problems of the month.
So the problem month has always been, if you go back to our coaching institute during the summer, where we could take little teams of teachers, up to 5 teachers, to the coaching institute, and we solve problems all based on these problem of the months and spend our mornings doing that. So we engage in problem solving. So we would have little pockets of teachers that would come back and implement the problem of the month in their classes, the ones that had been exposed to it. So over time, we wanted to see if there was a way to build this into our district culture. So it actually was just a couple of years ago that we had David Foster come out and do a problem of the month with the entire district, so that everybody could engage in the problem of the month and then go ahead and do something with their students.
But it started off primarily with the younger grades. They do it as a whole class activity, and you'll see them on the floor plane. The manipulatives are out. There's a lot of pair share. There's a lot of ideas flowing around, and I think it's a lot of fun for them. When it comes up to about 4th or 5th grade, we might do one activity as a whole group, and then we'll do some as homework, bring it back, challenge yourselves, get with a partner, share these ideas, and then the kids check in with the teachers as they go.
We've done 3 problem of the months this year, I believe, and the structure of it is it's a 5-level problem-solving activity, starting with level A, going up to level E. And level A is designed to be appropriate for primary grades. Level E would be appropriate tasks at a high school level. So we've tried different formats throughout the year, and mostly it's been contained within one classroom, and then a representative might have gone on to the next classroom and explained what they did.
The idea was that for each school to come up with a unique way of doing the problem of the month.
So originally we started off with the problem of the month coming from the district office that we were going to apply to our school, and Valley Mart debated it over, and we decided to go with 3. We started off with just coming up with an Olympic theme where the grades would do work in their classrooms, and then as they did it, they would actually take, or a small team would take the baton and then go up to the next grade level and meet with a small group of kids who had done it in a whole group. That was okay, but I think overall it was to come up with another way, another strategy for us as a school as to how to pull it off and really make this work, because we see the positive benefits from it. It's just how can we get that across to the kids? You know, the idea of a problem that takes over 24 hours.
But if it's 1/4 of the girls, almost 16 of the long
So it's like,
but that wouldn't make sense because half are boys. So these are all girls. 1/4 of them have short hair. So
and they don't give us how. Oh my god! But I don't get how she splits another 1/4 into 2 and has this as 4, and then this has another 4. So 8, and then that's because when you add all these up, these equal 32. Oh, I get it.
For this format that we tried today, which is the first time we tried it, we involved grades 4 through 8. And there's about 60 kids for each grade level, approximately. The idea was to start with 4th and 5th graders working together in groups of 4. 2 4th grade students, 2 5th grade students. We had 4 different classrooms jumble their students and sit down together to work on level A. They had 25 minutes. After the 25 minutes, we had a rotations. So now 5th and 6th grade, we're working together.
I know, but we're just trying to help you. It says a 4th of the girls have short hair, not a 4th.
And repeated the process of working together, summarizing 6th and 7th graders, then paired up across 4 classrooms, groups of 4, repeated it, summarized, and then we just culminated over the last 25 minutes with 7th and 8th graders working together in groups of 4.
The kids get to share with younger kids and share their thoughts. And then my kids, we did a debriefing over there, and they're like, yeah, working with the 6th graders, you know, they came up with different strategies of how to figure this out. So it's really a sharing of ideas.
As a district, it's something that we want to try and embody in our district culture so that the kids have an opportunity to engage in problem solving. One of the goals is to get that. I heard Brian say something about I'm starting to see more of the beauty of mathematics like I've seen in art and other things before, but I'm seeing that more in the mathematics. And so I think part of the idea of this mathematics can be recreational problem solving. So if you can get the kids excited, and it might only be a few kids initially, because not everybody is going to get excited, but you do see more and more little pods of kids that are getting excited about mathematics and problem solving. And so that's what we want to do. There's even a kindergarten version, which is what's awesome with these things at the primary level. So they worked on it and kind of passed and shared their work onto the 1st grade, and then the 1st graders had worked on it and passed it on to the 2nd grade.
Students become very familiar with the students they work with throughout the year. So in one sense, they're working with brand new people. They're more aware of themselves, their words, and how they're communicating. It forces them to be more aware they're communicating. Another thing is it just builds more of a sense of a community in the school, I believe, when they are having moments with, if you're in 5th grade, moments with 5th and 6th graders. And then everybody's at different levels of development, and then the standards across grade levels, different are very different. So it may be that the 8th graders they're only thinking about algebra and they've left some of the pre-algebra arithmetic that they're doing in 7th grade. So they may get stuck, have harder time with level B than a 7th grader who's been working on some of the content throughout the year.
I was surprised that the 5th graders enjoyed working with the 6th graders more than they did the 4th graders. I thought my kids would have liked to have taken the lead. And maybe that's just because this is the first time we've done it, and everybody was like, what am I doing? Where's the paperwork? Where am I going? I'm not sure, but there was like meeting up with these kids for the first time pretty much in an activity like this.
A lot of positive things that I see happened, getting cross-grade level interaction, students having to communicate not just to their peers that they work with day in and day out, but communicating to older and younger students themselves. Sort of takes advantage of a K-8 format, or would work in any format. And the idea was to fill out an activity log that said, explain what they were doing, what they had tried, what they would do next, or explain their solution.
We're going to give you about 5 to 6 minutes to fill out the reflection just like you did yesterday, answering the questions of where you're at, what you needed to answer, what you would do next, and whatnot, okay?
Now we have to fill out this activity log, and we're trying, you can write it down.
Yeah, we did, because we just, basically,
We sorted it out.
yeah, we sorted it by section. We sorted it by section. Did you find a solution? Yes. Yes, we did find a solution. A million times yes. Okay, explain. Oh, I hate justify. We proved it by sorting by section, and then there were no girls that had short red hair.
Can you all say goodbye to each other?
I guess the point is to have some type of a reflection sheet to see where you are in the problem, so that after everybody's had a chance to engage in the problem, then you can kind of share your thinking. And what you're hoping is that some of these strategies will come out from the students. Will have multiple strategies that they share, and then maybe rethink some of their ideas.
When we were debriefing, I said, tell me the positives, the negatives. They weren't really thrilled about the extra paperwork, which I am, because for the teachers, it's a way of really analyzing what are they doing and how are they doing it, and then we can go back and try to teach for those strategies to come out a little bit stronger. So it's kind of exciting, and they teach each other. That's the best part, I think.
Challenges that if we do it again that I could see, just coordinating transitions from room to room. And then definitely we weren't sure as teachers whether if in 4th and 5th and 6th grades they advance to level C, then with 7th and 8th, do we pick up at C? Or do we go back and let the 7th and 8th graders, 6th graders start at level A and get the experience from doing that? Because that's valuable.
But I think it's neat that different schools and different teachers are trying different things. There's different levels of engagement. The teachers that have been to the Coaching Institute or that have done Problem of the Months, they involve their kids, much more frequently than others. And so for those of us that are new, if you haven't done it, for the teachers that are new, I think it's important as a district that we allow the teachers the time to engage in the mathematics and do the problems themselves and model this status check of the posters and everything else, so that they see that this is one way to do it in the classroom, but then giving them the freedom to go out and, what's going to work with your kids? Do you want to make it a fair, here we are at the end of the year, we had the BMX bikes out there a day earlier, there's all kinds of stuff going on, and Brian or Jean said, you know what, we're going to make mathematics as a recreational thing too.
I love this over the way we have been doing it in the past. To me, it slows the kids down and makes them think. We did an activity yesterday, level A, and we had 4 different strategies of how to come up with one problem.
the point is, it's supposed to be a problem. If they came up with the right answer right away, it wouldn't be a problem. So then as a teacher or as a coach, when I'm going in there, you know, what questions do you ask so that you don't scaffold the thinking out of it? You know, trying to ask the kids certain questions that would guide them in the direction of trying to discover that from themselves without scaffolding.
How else, Adam? What other strategies can we use to solve this?
Since you know Jeff is a French maid, where does that come in order?
Half of the people at the party were boys, and it asked for girls.
So, ladies, what does that mean? What half of the people? So that's a challenge, and so just kind of asking those questions and being okay with them not coming up with the answer, still having these two answers that neither one of them were right, having the patience to think that when the processing that Jean was talking about as a whole class, and there are some, you know, some kids that were successful with their strategies, you know, let that information come from the kids.
Okay, so raise your hand. How many of you guys may have missed that one little step there?
To share that, at least with the pair that they were with. The more exposure the kids have to, you know, non-routine, open-ended problems that they're not used to, they have to think. And they have to come up with a strategy. And they have to think, well, what do I know? Can I make it a simpler problem? You know, can I draw a picture? Can I make a diagram? Is that going to be useful? Or is it going to take me down a dead-end path, you know, knowing when to go another way? So these problem of the months are an opportunity for the kids to challenge themselves and see what kind of strategies they have in their little bag of tricks and toolkit.
Okay, so that was the overview of the problems. I will give you 4 more minutes of classroom excerpt, okay, and we will be done for this week.
There are 5 levels, starting with level A that could be appropriate for primary grade students, all the way up to level E, which is appropriate for high school students, would be very challenging. More of what we're interested in than a solution is the process of getting there. So we've been working on problem solving in our journal, and our strategies were read it and write down the answer. What were some of the strategies we did with problem solving? Yes?
Making diagrams.
Diagrams are sweet. What else? What are some other things that we've seen modeled? Monica. Pictures are sweet. Victor.
Rules and patterns.
Find the patterns, the rules. Natasha. Separating the questions, like finding out exactly what it means. Yeah, who was it? Somebody, Russell Harmon in the other class for the desert crossing, listed exactly what we knew about it. So he deconstructed the problem. That's what we want to see here. Now, we see this level A here. When the 7th graders come in to join up with the 8th graders, there's going to be a period where we figure out what they've learned, because their work will represent what's been done in 4th, 5th, 6th, and 7th grade. So there needs to be communication. That is a problem-solving strategy, being able to communicate, understand where we're at. So it may be that they're going to talk about level A, level B, you guys are going to get on the same page. Then you're going to work on level C, making tables and diagrams to understand it. So when they come in, which they're about ready to, there's going to be a transition where you communicate, figure out what they know. Right now, you should be reading through all the levels. Read through level A, B, C.
2 times 4.
Cindy counts then to 1.
Yeah, the answer is 34. 2 times 4 is 8. 8 times 3.
C and then they can write 4 people, so. Not too G. That's fine. I'll just put G then. I know. Because I was gonna put second guess.
Another instruction for y'all. Instruction for y'all.
And then they divided 3, so then you.
Those who have a plate with a 2 after the alpha, you are going to go next door and join up. So there'll be an F group, there'll be an F2 group. You're going to sit down with the F2 group. There'll be a D2 group. You'll sit down with the D2 group. You can imagine then that some folks are coming in with D1. they're going to sit down with Kane and Joey. And so they'll be working with 7th graders. Cool. Do that now. If you are 2, head on out the door. Bien, here we are. Lovely to see you. Nice to have you. Thank you for bringing these plates. Let's see. What alpha symbols do we have? I see a D, some D1s. I have a D group right here. So D1s can sit here. How about Fs? All right. So 7th graders, soon to be 8th graders, soon to be in my room. I cannot wait. We're gonna have a lovely 8th grade year, just as we have already. Excuse me. Thanks. Appreciate it. I told my 8th graders this could be a moment of transition because your work will represent work that's been done in 4th, 5th, 6th, and 7th grade. So the 8th graders are going to be all eyes and ears with you for a moment as you share. Look, level A we felt pretty cool about. Here's my little diagram. I get it. Level B, I think we get it, but I don't know. I think this is the answer. I'm not sure how we got it. And that's fine. We are more interested in the process. We're more interested in the thinking than we are just an answer. Answers are pretty boring, actually. What's the juicy part is in getting there. So, get on the same page, be relaxed, have fun doing these problem-solving activities with each other, and I now give you the space. It is yours.
Okay, so yeah, as he said, how to get there is more interesting thing, and it gives you a lot of opportunity to bring students' ideas together, right? So homework is given to you. Please read it carefully and follow through, and I will see you next week. Have a good week, guys.